Yeah.
Okay, so there's like I started looking through this list, and like if you've got in front of you, it says 1A, write and analyze using function notation the equation of geometric lines such as the equation of altitudes, medians, and perpendicular bisectors. And there's so much there. I mean, I need to kind of constrain what you want to work on.
I can pull that up real quick, and I can tell you like specifically what I would like to work on.
Okay, if that's where you want to start, it's up to you. Some of them are more clear, like apply slope and the Pythagorean theorem, simplifying radicals. Those are more straightforward. You tell me where you want to go tonight.
Let me see where I am. Wait, okay. We can probably start with apply slope and the Pythagorean theorem, simplify radicals.
Okay, 1C. Do you want to get through all of this list tonight, or up to a certain place?
No. We just so this list is for like a few months.
Wow. Okay.
Or like a month or so. So yeah.
Okay.
Yeah. So we can just start there, and we don't have to do like I don't know how to.
That's enough. That's good enough for me. Pythagorean theorem, or PAG as I call it, just to be short with Pythagorean theorem, it's the relationship between three sides of a triangle, a right triangle, as you know, A, B, and C. It specifies that a squared plus b squared equals c squared.
Yes.
Now there are certain numbers that work really well. Like if I tell you that a equals 3 and b equals 4, you will find that c equals 5. These are called Pythagorean triples.
Yeah.
Or as I write, PAG triples. Okay. The next one that you might see is like 5, 12, and 13. Okay. And then another one might be like 8, 15, and 17. And these actually go on forever. Like there's an infinite number of these that you can have. Now, first example is I give you a triangle and I tell you that A is 6, B is 8. You have to find the value of C.
Okay.
So to do that, you're going to take 6 and square it, plus 8 and square it equals C squared. 6 squared is 36. 8 squared is 64. C squared equals 100. Now, I know that you probably know that the square root of 100 is 10. So C is equal to 10. But for now, we're going to write it as the square root of 100. If you didn't know it was 10, you would break it apart into its prime factorization, as I'm doing here. And you would circle pairs.
Yeah.
And you would realize that both of these numbers come out. So C equals 2 times 5, the square root of what's left over, which is 1. So it equals 10 square root 1, or just 10.
Okay.
Now that's pretty straightforward, but what if I give you a problem where it doesn't reduce nicely? You have to be able to do problems like this, where I tell you, and I'll just draw another triangle here, that they tell you that, oh, A is 8, B is 10, and I want you to find C for me. So do that. I'm going to look up some other problems related to slope. I'll give you 60 seconds to look at that, please.
Okay. you give me 1 second? I'm gonna grab some paper.
Okay, no problem.
Okay, I believe I have the answer.
Okay, so the answer here is that 8 squared plus 10 squared equals c squared. 8 squared is 64 plus 100 equals c squared. So you have 164 equals c squared, and you take the square root of that. So if you break this apart, you get 2 and 82, 2 and 41. 41 is a prime number. You should get 2 square root 41 as your final answer.
Yes, I did.
Great. Okay, so that's just a problem that, I mean, we just did a problem. It's not all that interesting. I'm going to give you 3 points. I'm going to tell you that this triangle ABC has points 3 comma 7, -4 comma -2, comma 3 comma -2. Now, if you have graph paper, it would be good to graph these. I'm going to graph them for you just so you've got something to go off of. So 3, 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. That point's right up there. -4, -2, 1, 2, 3, 4, down 2 is right there. And then 3, -2 is right there. You can see visually that this is a right triangle. Okay. Now, I could just as well, and we'll call this A, B, C. So this is A, this is B, and this is C. I could ask you, what is the distance from or of AB, line segment AB? And if you've been paying attention to what we've done for the last 2 problems, I'm asking you to find the hypotenuse of the right triangle. But before you can find the hypotenuse of the right triangle, you have to know the base and the height.
Height, yeah.
Okay. So you can count.
Yeah.
This is 7. And this one is 10.
Oh,
So I want you to see if you can figure out what the hypotenuse is for me, please.
Okay. Um, it's just the square root of 149.
That's right. Okay. So the simplifying radicals we should just look at briefly, because it's something you're pretty good at already, but we'll just do a couple of things. So let's say that the triangle has side square root of 8, b equals 6. What does c equal?
Okay. It's 2 root 11.
You got the square root of 44 and 2 root 11.
And then,
okay.
yeah.
Okay, good. All right. Slope and Pythagorean theorem. Okay, applying radicals. All right. So let's do a sort of a related, maybe a synthesis problem here. Let's say that you know that this is 4 and this is 5. And there's another triangle here where this right here is also 5. I want you to find the value of, we'll call this x over here.
Yeah, I'm confused.
So the lower picture here is a triangle. Can you find this third side of the triangle?
Yeah.
Okay, so do that for me, please.
Okay.
Find C.
Okay. It's the square root of 41.
Okay. So
I see now what I'm supposed to do.
Okay.
So it should be 41 plus 25. So it is just the square root of 66 is what x is.
Okay. So you got, does that reduce?
It does not.
It does not. Good. Okay. So all of this leads to the following problem that you often see. So you're presumably in some sort of a room.
Yes.
And the room has dimensions, like maybe it's 10 feet by 12 feet. Okay. And it has
my room actually might be a square. If I'm being completely honest with you.
They're almost always one not quite square. It's like 10 by 11, 11 by 12. Builders do that because there's somehow, if it's a square room, there's something wrong with it. There's also a wall in one corner of your room, for example. And let's just say for some reason you have 15-foot ceilings, so they're really tall. And you want to run something from this corner of the room down here at the floor level all the way up to the ceiling up here. And you have to go to the store and cut it perfectly. A lot of this is unrealistic, but let's just say that's the case. And you need to know exactly how long that is. Okay, so you might be thinking to yourself, well, how does this relate to the previous problem? Well, the way I've drawn this, it may not appear this way, but there's actually a right triangle on the floor. Would you agree with that? Like where one side comes to the other side. Is that a right angle in your room, or the room you're in?
I think so.
Well, yeah, it is. Okay. Now, it doesn't seem like it, but if you were to draw a diagonal on the ground, this diagonal on the ground, it would meet up with the wall at another right angle.
Okay.
So do you see how if you find the diagonal C, because you know the height of the room, you can find this length here of this piece of string?
Kind of.
So the first thing you're going to do here is I want you to calculate
solve
C.
for C, right? Yeah.
Yes, calculate C.
Okay. Okay, it's 2 root 61.
Okay, how did you get that so quickly?
Well, it's 12 times 12 is 144. 144 plus 10 because that, and then I just divided by 2, got 122, and then again I got 2 and 61, and 61 you can't do anything with it.
Perfect. Okay, now you've done this type of problem twice now. What is the math operation you're going to apply to C?
I'm actually gonna leave it as the square root of 244 because we don't want to use the 2 root 61.
That's right. That's right. So if you can look ahead, you actually don't have to simplify that. So 15 squared is 225. So we're up to
244 plus 244 plus 225, right?
Equals L squared.
Okay, so it's 469. 10, 19. It
So
might.
actually,
I don't know if it's
I
I don't know
actually
if you
don't.
can do anything with it.
Yeah, I actually don't know either. They that's one of the limitations of me doing this is I don't pick nice numbers. This one does not reduce. So L equals the square root of 469 feet. So sometimes they ask the question this way: um, if you purchase 21 feet of, I don't know, string or bungee cord or whatever rope, will it be enough?
Okay.
And you're supposed to realize that, okay, well, the square root or 20 squared is 400. What is 21 squared? I'm sorry. Yeah, maybe that's not helpful. What's 21 squared? Do you know?
21. Well, we could use 20 square, which is 400. So we know it's like 400 and then
So
21.
is this number I've given you here, is this number bigger than that number?
No, it's not. Oh, it is
It
400.
is. Yeah, it is. 469 is bigger than 400. So you know that it is not enough.
Yes.
Great. Okay, so I'm going to go back to your list of questions without some more, I don't know, guidance. I'm going to call 2C done. This idea, though, of coordinate geometry, which is in 2B, I want to briefly discuss that, coordinate geometry. And we sort of did that. What it is the inputs to the problem are points. They tell you that a triangle has a point at here, 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 here.
Okay.
Okay. So, for example, let's say that a triangle has a right angle at 0, 0,
Mm-hmm.
and a height of 4 and a vertex at x comma 0. If the area is, I don't know, 32,
Mm-hmm.
what is the value of x?
What?
So the first step in all these questions, and this one's not super exciting, but the first step is to try to draw a triangle.
Yeah.
So, or whatever it is. So 0, 0, and then it says it's got a height of 4. So we'll say that that's 0, comma 4. And then we don't know where it is, but somewhere out here is a length x,
Mm-hmm.
because it's got another vertex at x comma 0. So what is the area of this triangle?
Something. Oh, 32.
It's 32. But we know that more generally that's 1/2 base times height.
Yes.
Do we know either of those values?
Not really.
We know the height.
Yes.
So the height is
Some number.
4.
1/2.
4.
Oh, it is 4. Okay. Right.
Okay. And do we know the base? Well, we know it's x, so we could make x b.
Mm-hmm.
Is there enough here to solve for b? Can you figure out what number goes here?
Yes, I can.
Okay.
So it's I think it's 56, I believe, but
Okay, so we're solving this right here. 32 equals 1/2 b
oh,
times 4.
right. No, it's 16.
Okay, so half of 16 is 8. 8 times 4 is 32. So b equals 16, and that means that x. This is really, I mean, it's way off here, but this is 16.
Yeah.
Okay. So another type of problem that you might see is where they give you 3 points, and you have to determine whether or not it's a right triangle.
Okay.
Okay, so I'm going to try to explain that after I find an example problem, which I'm trying to do right now. Okay, so here is the example problem I want to give you. What I've noticed is that a lot of a lot of instructors, they don't actually want you to graph these things, which I don't agree with. I think the visual is really helpful here. Okay, so
Okay.
if you don't have a ton of room to graph them, you should at least sort of say, okay, let me call that my origin. And the first point's about here, the next point's about there, and the other point's about there-ish, right?
Okay.
Like it's not exact. I'm not even going by one. I'm just sort of putting them in the position. So if we were to draw a triangle through this, let's call this A, B, and C, this is A, this is B, and this is C, which vertex or which of the 3 vertices is the likely right angle based on the way it's drawn?
Probably B.
Probably B. Agreed. Okay. So we think maybe this is a right angle, but we don't know.
Yeah.
There is a way to find out. It requires you to find the slope of AB
Okay.
and the slope of BC. So I'd like you to find the slope of those two, the slope between A and B and the slope between B and C.
Okay. Now you probably have some sort of super genius way to do this, but for me it's going to take me a while.
Slope formula.
What's the slope formula?
Okay, so the slope formula is?
Well, just for the slope, it's y2 minus y1 over x2 minus x1.
That's it. That's all you've got to do here.
Okay. Wait, that's wrong. Minus 3 over. So it's negative 2.
So you got the slope of this one as -2?
Yes.
Okay.
Of AB.
Okay. And for BC?
I do that right now. It's 1/2.
Okay. Do you recall how to determine whether 2 slopes are perpendicular?
It's the opposite reciprocal.
Yes. Or the product of the slopes. So AB times the slope of BC. If this equals -1, you know that they are perpendicular,
Okay.
which is how you get opposite or flip the sign and take the reciprocal of the number or the fraction. So these are perpendicular. So this is a right triangle.
Okay.
Okay. Now there's another way. There's another way to do this. All right. And I'm gonna attempt to do that here for you. I'm gonna draw it better this time though, because it will be useful for learning. So I'm gonna pretend like my origin is there, and I'm gonna go -9. And then up 3. And my next point is 13. I'm sorry, -3, -9. So 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the last point is 13. All right, so there's your points there. All right, so now if we connect these 3 nicely, which I'm going to attempt to do here. If we connect them nicely, okay, this is a right angle, okay? There's another way to determine that this is a right triangle. It's more complicated, but we can draw two other triangles here, or three other triangles here. Let me switch colors in my with my pen here. The first triangle we can draw is this right triangle right here.
Okay.
What is this distance here? Maybe, hopefully it's easy enough to count.
5, yeah.
5. And the vertical distance?
Smaller. 12.
Okay. So what I want you to do is find the third side here using the Pythagorean theorem.
Okay. Switch. That's 169 again.
Okay.
And we already know that nothing happened, so it's just the square root of 169.
Okay. Also known as 13.
Oh.
5, 12,
I don't know
13
that.
is a Pythagorean triple. Okay. So we're over here
Right.
on this other one. This other one is it's 16 across, and then vertically it's 8.
Okay.
So I want you to find the third side here again, please.
Yeah, sorry. What's the square, or what's one with 16 squared?
256.
Thank you. Okay. Okay. There's a pair. There's a pair. There's a pair. So it's 8 root 5.
Not getting that.
Oh my god.
Maybe that is right. Yeah, I guess that is right. It's the square root of 320 though. Can I leave it as that
Yeah,
for the time
yeah.
being? Okay. All right, and then give me the last one here.
Okay. Right.
I'm not giving you. Let me just make sure I'm giving you the right numbers. This is
151.
This is 22, and that's 4, and then.
Well, I can use either one of those, right?
And I actually gave you the wrong number down. My drawing. Why is that wrong?
Hey, the out. Sorry, my dog's just right where I need to be. Yeah, you gotta get out of here, Hayden.
I've got this in the wrong spot. Okay, I've made a complete mess above this. Let me do it differently. I apologize. That's one of the reasons why I don't like drawing is that if you make any mistakes at all, you just don't do it. So we're going to draw a triangle here, and actually this isn't going to work either. Okay, we're gonna move to a new topic because this one is has been worked out sufficiently. Okay, so finding angles and sides in a large complex diagram. Okay, it used to be that your class would get a pretty substantial problem, like they'd give you two parallel lines and then they'd cut it, and then maybe they'd cut it again, and then maybe they'd produce this with this with this with this, and then maybe they'd even I don't know, maybe they would they would even incorporate some circle stuff. So they would say, oh, what if you had a circle like that? And it was such that like they'd give you angle 1 and you'd have to find all the other angles in the drawing.
Okay.
Which you know, it's like, well, how far can you go? So let's say angle 1 is 40 degrees. What is this angle right next to it?
It's 140 degrees.
140 degrees. What is this angle down here?
It's 140 degrees.
And then this one over here is 40 degrees.
40 degrees.
And then how about this one down here? And these are parallel. This angle right here.
Okay, so that's 40 degrees.
This is 40 degrees, and that's kind of the same discussion. Okay, that's 140.
Yeah.
That's 40. That's 140. Okay. And let's say that's a right triangle. So now what's the angle measured down here? This is 40.
Which angle?
This is 90. What's this one down here?
Wait, hold on. I know it's 50 degrees.
It's 50 degrees. Good. Okay. And then let's go up to let's say that these two sides are the same. That means that this is an isosceles triangle here. So if it's an isosceles triangle, that means that this is also 40 degrees. Is that okay?
Yeah, yes.
So since all three angles in a triangle have to add up to 180, what must this angle up here be?
This 40 degrees.
So no,
it's 80. It's 80.
It's 100 degrees because 100 plus 40 plus 40 is
right. Yes.
180. Yes. So then, what is this angle right here above it?
Also 100 degrees.
Also 100 degrees. And then the angle here must be
40.
40 degrees. Okay. Now, you know that the angle right here and the angle right here, like they add up to 180. So if this is 100 degrees, that means this is 80 degrees.
Yeah.
All right. And this one right over here must be 140 degrees. And this is 80 degrees. Okay. So now, if this is a right angle, that means this is a right angle. And this is a five-sided polygon, and five-sided ones have an interior angle measure of 540 degrees. So what's this missing angle up here? You got 140, 80, 140, and
90.
So they have to add up to, it has to add up to 540. So you got 140 plus 140 plus 80 plus 90 plus x has to equal 540. So this is 280.
Yeah.
360. 430.
So it's 110 degrees.
110 degrees. And since this is a straight line, what's the angle measure here? These two have to add up to what number?
Well, I don't know which angle you're talking about.
This one right here.
Oh. That's 90.
It's not 90. They have to add up to...
Is it 110? Wait, well, no, because that needs to be 80, so it's 70 degrees.
So it's 70 degrees because it's up to 180.
Mm-hmm.
This angle and then the one I'm pointing at right now, 140 and this angle, they have to add up to 180. So this one is 40. Mm-hmm. So what is this angle up here?
It's 70. Wait, let me think. It's 110 and it needs to be 180. So it is 70 degrees, yes.
70 degrees, okay. Great, okay. So this continues. Now, what I didn't do is I didn't the way this problem would be labeled, and I don't remember, I think we started with this angle right here. I think this was first. Mm-hmm. Your problem, I mean, I'm just gonna pick like this would be A, this would be B, this would be C, and this would be D, and this would be E, and this would be F, and then G, and then H. Like that's how it'd be labeled. You'd have to find all those, but you'd have to do this progression that we just did.
Okay.
So I guess the point is that there's really two things that we did in this. Well, not two. Maybe there's three. We know that when angles are supplementary, excuse me, they add up to 180.
Yeah.
We know that three angles in a triangle have to also add up to 180.
Yeah.
In a four-sided polygon, like a square or a rectangle or just a quadrilateral with four sides, they add up to 360. We also talked about that a five-sided shape, and if every side is the same, it's called a pentagon. It adds up to 540. So these are things that we use to try to figure out different values.
Okay.
All right, so let's look at something else here. It says write proofs, determine properties of lines, angles, and polygons. Writing, reading, and critiquing both two-column paragraph proof, including but not limited to 100 degrees in a triangle, some of the interior angles in any polygon. Okay. So the sum of the interior angles in any polygon has a formula, and I use S for it. It's n minus 2 times 180.
Yeah.
So we're gonna make a little table here. We're gonna fill this out here. Let's say it has three sides. I want you to use the formula and verify that it's 180.
Okay.
So 3 minus 2 is 1. 1 times 180 is 180.
Yeah.
Now, what if it has...
but then how is n... Right, okay, so then 4 is 360, and 5 is 3 times 180, whatever that is, 540.
So these go up by 180 each time.
Yeah.
Okay, so sometimes they give you questions like, let's say n is 12. What is the sum of the interior angles?
Which interior angles?
The sum. What is the sum of the interior angles if the number of sides is 12?
Oh, 360. It's always... Wait, no. It's 1,800.
That's right. Okay, so that's potentially useful depending on the type of problem you're looking at. Let's look at a triangle for a moment. Let's look at a nice triangle here. I'm going to draw a nice triangle right here. I'm going to tell you this is an equilateral triangle. What is the angle measure of each one? And if you're not sure, start with the sum being 180. The sum of these
so
three
it's wait, so they're all equal. So we divide 380 by 3 and we get 60. So each side is 60 degrees.
Each side is 60 degrees. What is this angle right here? This is a straight line.
What do you mean?
What is this angle measure?
Oh, 120 degrees.
120 degrees, because these add up to 180.
Yes.
Okay. Now let's try a different type of triangle here. These two are the same.
Okay.
This is 80 degrees. Give me this angle and this angle. They are the same. So the three angles of the triangle have to add up to 180.
So they're both 50 degrees.
They're both 50 degrees. What is this? What does this angle measure over here on the left?
Oh, it's 130 degrees.
130 is the sum of this angle and this angle. Would you agree?
Yes.
Now, why is that? Any idea why that is? Because it's also, this 120 is the sum of these two.
I have no idea why, but it's yeah.
Okay. Okay. All right. Let's try another problem here. So let me just say that this is x degrees.
Okay.
What is this angle right there in terms of x? Meaning, like, you have to use x in your answer.
Okay, so x plus some number is 180.
Okay, so let's call it y.
Okay.
But you can't use y, so it's x plus y equals 180. So how do you get it so that you don't have a y here using this equation?
I don't understand.
That's okay. I'm being a little bit deceptive because I don't want to just tell you what to do. I want you to solve this for y.
But we don't have x, so it's not possible to solve for y.
So it's not possible to get a numerical value for y, but it is possible to get an equation for y, which is...
Oh, it's y equals 180 minus x.
Okay, so let's redraw our picture here. If this is x, what is this right here where I'm pointing?
180 minus x.
Okay. So now, what is... let's give these some other numbers here. This is we'll call this B and this C.
Mm-hmm.
So what do we know about these three angles in the triangle?
Oh, those angles equals x. B and C equals x.
Well, we don't know that yet. Like, we're kind of making a proof without doing a proof. So I'm asking you about, if you just if you didn't have this over here, like if you just were looking at the triangle, what do you know about those three angles in the triangle? What do they add up to?
I don't know.
Well, what did the three angles up here add up to? What did these three angles add up to?
Oh, they added up to y.
To 180. What did these
Or
three
180.
What did these
Right.
three
Okay,
Okay,
those
so
three are 180.
so these three angles add up to 180. 180 minus x plus b plus c equals 180. Is that what I just said?
Yes.
Great. I want you to solve this for x.
Solve for x. Yeah, I'm still really confused. It just doesn't make any sense to me. Wait, so we should have 180 minus x equals 180 minus b minus c.
I want you to get x by itself on one side of the equation.
Okay, so then we subtract 180 from both sides.
Okay.
And we get negative x equals negative b equals negative plus minus negative c. So we multiply both sides by -1.
Okay.
And we get x equals b plus c.
Is that what you just said before?
Yes.
There's value in you doing this on your own. That's why I had you go through this approach.
Okay.
Now, I don't know that you could do this on your own without being pushed into the right direction, but you just proved what's called the exterior angle theorem or something, exterior triangle angle theorem or something.
All right.
Which says that the exterior angle x equals the sum of the other two angles that are not that the one that's not supplementary.
Okay.
So this is extremely useful because let's say I give you a triangle and I tell you that this is 43 degrees and I tell you that this side and this side are the same.
Yeah.
Sorry, I gave so what is this angle right here?
137.
Sorry, I'm 143. So this is 30. This is 37.
Okay.
And then this, because this is an isosceles triangle, this one is also 37.
Yeah.
Now I know you can add them up, but you also can say, oh, this angle 37 plus this angle over here, which we don't know, has to equal 143. It must be 106.
Okay.
So here's how it's used more generally. I give you a triangle like this, and I just pull off one of these, and I say, oh, this is 165 degrees, and this one is 32 degrees. What is x? Well, you're supposed to realize that, oh, this angle equals the sum of these two.
Okay, so I subtract 32 from x, and I get 130. Oh, wait, I get 133.
Right. That doesn't make sense in this picture, but, you know,
Yeah.
whatever. It's part of that. So if I give you a triangle like this, and this angle right here is pretty big. I'm going to call it 172 degrees. And we know that, let's just say this is 102 degrees. What is x?
Okay, so that's 8 degrees. So that first angle is 8 degrees.
Wait, you're not supposed to find that one. Like I agree, it's 8 degrees, but you're supposed to realize that it's this plus this equals that.
Oh, okay.
That's
so it's 70 degrees. X is 70 degrees.
70 degrees, good. Okay. All right, so we're going to close out with a couple of PAG questions here. Let's say that I tell you that A is 10, B is unknown, and C is 26. How do you find B? This is 10, this is B, and this is 26. What's the relationship?
Okay. Yeah, okay. So it should be 10 squared, or 100. 100 plus B squared equals 26 squared.
Right. So 26 squared is like, it's like you either
number.
know it or you say, okay, it's 26 times 20 plus 26 times 6.
Some number. 460 plus, I don't know what 26 times 6 is, though.
Well, this is like doing 20 times 6 plus 6 times 6.
Oh, okay, 156.
So give me the number that goes here.
The number that goes, okay, so it's 460 plus 156. So let me add that. Wait. 616.
Okay, so it's 676. So try, you'll have to look back and make that correction. When you subtract 100 from both sides, you get B squared equals 576. You take the square root of both sides, B equals 24. Now you should have realized, oh, this is a 5, 12, 13, but it's not. It's kind of like a 5, 12, 13. It's a 10, 24, 26. How did I go from these set of numbers to these set of numbers? Multiply them by 2.
Yeah.
So let's say you know like a 3, 4, 5 works. So let's say I give you a 12, something, and 20. What's the middle number? How did I go from these set of numbers to these set of numbers? What did I multiply by?
Oh, you multiplied by 4.
Okay, 3 times 4 is 12, 5 times 4 is 20, so what's the middle number here?
16.
16. All right, so we'll stop there. And I will be sending these notes out to you as a PDF.
Uh-huh.
And I appreciate you scheduling, and let me know when I can help again.
Uh-huh.
Thanks, Zane. Have a good night.
All right.
Bye
Have a
now.
good night.